In this lesson, we're going to take a look at solving three-variable linear systems. So we've worked on solving equations with two variables, but often in applications we have many more variables than just two. So we're going to start off looking at these linear systems. Now, a linear system here means we have all of our variables, x, y, and z, or whatever letters you want to choose there, they're all going to be to the first power. Now, when we use substitution, we need to have one of our equations equal to one of the variables. In this case, it already is. That's kind of handy. And so if it's not, just solve it for x, y, or z. Whichever one is kind of a matter of choice and a little bit of strategy. And let's just plug this in for each of these equations and see what we get. Plugging into the first one here, we get 2x minus y plus, we're going to put this x minus y in place of z, and we get that. Good idea to get in the habit of writing those in parentheses, because some weird stuff will happen there. And we're going to keep track of what equation that comes from. Now let's try equation 2 and substitute there. Again, we want to use some parentheses wherever that z is, and we're going to take x minus y, plop it in place of that z. And now we're all ready to simplify these guys. Here we don't have anything to do with those parentheses, so we can just get rid of them. Just erase them and then combine like terms. 3x minus 2y equals 0. And here we need to distribute first. Don't forget that. We got 4x and 4y. That's going to be minus 4y. Combining like terms, we get 5x. We get minus 2y equals 4. Now that we've got two equations with two variables, x and y, the same variables, that's important. Now we can just solve for x and y. So we bring these two equations down together. We can use any method we want. We could substitute again, but substitution is not going to do any good because we don't have an x or y all by itself. We've got a 5, a negative 2, a negative 2, a 3. It's in the same form. They're both in standard form, so it's all set up for elimination. So let's go ahead and just subtract these equations because we noticed that we've got negative 2y and negative 2y, and a little subtraction there will work nice. We have 3 minus 5x, that would give us negative 2x. We have negative 2 minus negative 2, that's like adding, that becomes 0. And we have 0 minus 4. When you're subtracting, be very careful with your signs. That's going to be negative 4 because we're subtracting here. If you'd like to go ahead and multiply these all by negative 1 and then change this to adding, you'll get the same result, and that's fine. It's always good to take time and be safe. Divide by negative 2, and we find out that x is 2. Now I'm going to take this equation right here, and we're going to substitute for x. You could do it for the other equation too, it doesn't matter. But let's go ahead and substitute, plug 2 in, because we know that x is 2 here. And we've got 6 minus 2y equals 0. Subtract 6 from both sides. Divide by negative 2, and y is 3. So we've got x and y. Now it's just time to find z, and we can do that with this equation here. So z equals 2 minus 3. So z equals negative 1. And let's put that all together. X equals 2. Z equals negative 1. Y equals 3. This next example, let's use some elimination. The directions you say Gaussian elimination. Gaussian elimination usually uses matrices, but the idea that Frederick Gauss I guess kind of used was to solve one of these equations for z, plug that in, solve this one for y and z, plug z in to get for y, and then plug those into the top to get x, y, and z. So let's see what we can do. We want to add and subtract these equations and make them go away, to make variables go away. That is, to make them eliminate. So let's go ahead and call this E1, E2, and E3 to keep our heads on straight. Okay, and so let's go ahead and take if we add equation E1 or E2 and E3, these x terms will go away because they're exact opposites. So let's do that. Let's take those. Let's copy them down and add them. So we've got our equations, E2 and E3, and let's go ahead and add these together. And the x's cancel, that's nice. 2y plus y is 3y, and 4z plus z is 5z, and 4 plus 0 is 4. So we've got a new equation there, and let's try to eliminate x and it's from a different equation using a couple more variables here. A couple more of the equations, that is. So let's try to use E1 and E2 to make the x go away. We notice that E1 has a 2x in it, so let's take E2 and double that. And when we double everything in E2, we get 2x. We're looking at this equation up here, doubling everything there. 2x plus 4y plus 8z equals 8. And subtracting these guys, the x's go away. We have negative y minus 4y. That's going to give us negative 5y. We have positive z minus 8z. That's going to be negative 7z. And 0 minus 8. That is negative 7. All right, so we've got a couple new equations here. And now let's see if we can get rid of the y's. So kind of rewriting just so we can see what we're looking at. Pulling these two equations together, we've got a new little system with just two variables, y and z. And let's try to get that y out of there by multiplying the top one by 5. Let's multiply this guy by 5. Let's multiply this bottom one by 3 and see what we get. So we get these equations, 15y plus 25z equals 20, and negative 15y minus 21z equals negative 24. All right, and now they're all ready to add, so we can add these up, and the y's go away, and we end up with 4z equals negative 20 plus negative 24 would be negative 4. Dividing by 4, we got z equals negative 1. Now pulling together several of these equations. You don't necessarily need to rewrite this, but I'm going to just kind of keep it organized there. We've got that equation, which tells us about x, y, and z. That one tells us about y and z. And that one tells us about z. So all these together gives us everything we need to solve this system. We already know z, of course. It's negative 1. Plugging that into the second equation, we get negative 5y minus 7 times negative 1 equals negative 8. And subtracting 7, we get negative 5y equals negative 15. Divided by negative 5, y equals 3. So we found y, we already know z. And finally, plugging into this top equation, substituting both of these back here, we get 2x, x minus y plus negative 1 equals 0. So 2x minus 4 equals 0. 2x equals 4. Divided by 2, x equals 2. All right, so there we have our answers. Now we have, to put it all together, x equals 2, y is 3, and z is negative 1. Now Gaussian elimination works a lot better with matrices. We can keep things nicely organized. Let's see how that works. Let's make this into an augmented matrix like we did with two variable systems. So we're going to take the coefficients and Put them all in a matrix along with the constants. And we get our augmented matrix. Now, we're going to go ahead and try to work this out by hand, just for some good experience. You won't necessarily be expected to on a test, but we'll show you how the calculator can work, but I want you to see how this can be done reasonably easily by hand. So our first goal is to get all of these bottom ones here to be 0. Okay, we want 0, 0, 0. In the end, we want this matrix here. A diagonal matrix with ones on this diagonal, all zeros in this corner, zeros in this triangle corner, and 3 numbers here. Those will be our X, Y, and Z. So, I'm going to go kind of quickly through this just so you can experience it and see what's going on, all right? So, my goal is to get this to be 0, then this one, and this one. So, let's start with these 2 zeros here. Let's go ahead and add these 2 rows and copy the result down at the bottom. And adding the rows, we get 1 plus -1 gives us 0. 2 plus 1 gives us 3. 4 plus 1 gives us 5. And 4 plus 0 gives us 4. The other 2 rows I just copied. Okay, now I'd like to make this 0. Okay, so what we're going to do here, we're going to save a couple steps. All right, we're going to take 2 of these rows, multiply this by -2, and add at the same time. So we're allowed to add a multiple of a row. So here we go. I'm going to 2 for 1. I'm going to multiply this by -2 and add to this. We get 0. -2 times 2 is -4. -4 plus -1 is -5. -2 times this is -8. -8 plus 1 is -7. -2 times this is -8 plus 0 is -8. And I'm going to copy down the next row. So you see I kind of did 2 steps at once there. We added a multiple of a row that way. Okay, and all right, let's keep going. We got our 2 zeros there. We would like this to be 0 now. Okay. This was going to be a little trickier because we've got to make this and this be the same. So let's go ahead and take a step. Let's multiply this row by 3 and this row by 5. So multiplying, again, this row by 3 gives us 0, -15, -21, -24. Multiply this guy by 5, 0, 15, 25, and 25. Now we're ready to add these, so I want to make this be 0. Again, we're trying to get this whole triangle to be 0. So let's add row 2 plus row 3. I found a little error here. That should be 20 because we did back here we did 4. We did 5 times 4. Should have been 20. So we'll make that a big ugly 20 there. All right. Copying down the first row, we got that there. Let's go ahead and add the rows. 0 plus 0 is 0. And -15 plus 15 is 0. And -21 plus 25 is 4. -24 plus 20 is -4. And while I'm at it, I'm going to go ahead and take this middle row and drop it back down and divide it by 3 again. 1/3 of row 2. Just to take those numbers back down again. -5, -7, -8. Guess I could have done negative and made them all positive. But there you go. Now let's go ahead and clean up this last row by dividing by 4. So let's take 1/4 of row 3, and I'm going to go write it on the other side of the page here. Now at this point, what Gaussian elimination says is go ahead and take these numbers here and write them as equations, which is exactly what we have up here. Notice this 2, -1, 1, 0, 0, -5, -7, so on and so forth. Notice those are exactly the same as these. There's a system right there, and we just did this. 2, -1, 1, 0, -5, -7, -8, and 1, -1. That's the system, the matrix that we've ended up with. So Gaussian elimination says go ahead and do the matrix stuff here, and then basically rewrite the system and do what we finished off the last one. You can also just continue with the matrix, and I'll real quickly go through so you can zip through this. You don't have to write it all down, but I'll show you how we can real quickly cancel out all these and finish off this system. So what I'm going to do is this. I want to take and add 7 of these plus these, and that's going to make this go away. And at the same time, I'm going to add row 1 and row 2. Actually make that, we're going to subtract row 1 and row 3. So to start off, let's subtract row 1 minus row 3. We get a positive 1 out here because 0 minus negative 1 gives us 1. Now, notice I've just copied row 3 down here because we're just continuing that. We're going to take 7 of these plus this row 2. 7 row 3s plus row 1. So let's try it out. We have 0. 7 times 0 plus 0 is 0. We have 7 times 0 plus negative 5 is negative 5. 7 times 1 plus negative 7 is 0, and that's what we're going for. And then 7 times negative 1 is negative 7, plus negative 8 is negative 15. Now we're getting close. I'm going to just copy down row 3 for this next one, because we've already got our 1 where we needed it here in this last row. I'm going to go ahead and copy down a 1/5 of this, actually negative 1/5 times row 2. That's really just dividing it by negative 5, and we get 0, 1, 0, 3. That's good. And now, last but not least, we've got to cancel this out. So let's go ahead and do this. Let's take negative 1/5 of this and add that to row 1. Something like this, negative 1/5 of row 2 plus row 1. Well, we already have negative 1/5 of row 2 over here. So we get 2 negative 1/5 times this plus this. Negative 1/5 of this is 1 times this is 0. That's what we're going for. Negative 1/5 of 0 times plus 0 is 0, of course. And now negative 1/5 of this is 3 plus this is 4. And there we have it. We're almost done. Let's divide the top by 2 and we're done. And now we've solved our 3-variable system with matrices. So we have x is 2, y with 3, z is negative 1. Okay? Once again, we could have these last 3 steps we can do as we did, or from this point right here, we could go ahead and just rewrite these. We can rewrite these here in terms of these equations and then just solve using substitution. That's called back substitution. So either way works fine. Okay, but there you go. Now what we're actually going to be worried about now, what we do want to master, is using your calculator. So we can go to our calculator and just enter this matrix for this one example: 1, 1, 10, 2, negative 3, 1, and 5, 2, 2, 2, and 20. So go enter this in your equation, your calculator. Go to your matrix, just like we did with 2-variable systems, and we want to get our reduced row echelon form. Okay, RREF. Now the steps were in the handout from 5A, so go use those same handouts. This, by the way, this is a 3x4 matrix. So you're going to make a 3x4 matrix, choose reduced row echelon form on your calculator, and it should spit out a nice matrix. Whoops, not like that. It should have 1s on the diagonal, and it will give you some most likely decimal answers for on the right side. And this is your goal, but we get something a little different for this. Try it out and see what you get. You should get 1, 0.8, and 7, with 0, 1.2, and 3, and then we end up with a 0 here and a 0 here. So what happens is all of these cancel out, and this is what we call a dependent system, because we don't get just a single answer. And the reason is because these two equations are the same. The top and the bottom are the same. Okay, so it's a dependent solution, and so what that means is z can be anything you want it to be, and so everything can be defined in terms of z. So these equations that we have left here are this. We have x plus 0.8z equals 7, y plus 0.2z equals 3, and solving these, we just get that x is equal to 7 minus 0.8z, y is equal to 3 minus 0.2z, and z is just z. Okay? Now, if you do get numbers here, then you end up with, if you have ones all the way down and numbers all here, those are your solutions just like we had before. But if we get something where I have straight zeros, this is what we call dependent solution, and these are actually planes that intersect at a line. Well, we'll look at that more in the future there. That's how you do it there. So we can solve systems of three variables in all kinds of ways. Okay, so try those out on the next page and see what you can do. Good luck.